Hello everyone, welcome to ENG3201, Computer Aided Engine Drawing lecture session for the asynchronous mode. For this week lecture, we're gonna go over pictorial projection. It's basically one of the type of projection method that allows you to to create a 3D object, to represent an object, uh, the whole three dimension of it. So basically, under one drawing means that one way for you to look at this is now if you create a multi-view drawing, right? You only view from two dimension, so XY or YZ or XZ. Now it only give you one. I'll say a view from one dimension. Now, pictorial projection is basically an art of representing a 3D object in one single picture. So what does it mean here? You only need to draw one pictures or one object, a drawing of an object in a certain way, okay, that shows all three dimensions. So that's one way for you to look at it. All right, so yeah, let's begin. All right, first thing first, what are the topics? I'm gonna go over again multi-view drawing, axonometric drawing, oblique and perspective projection. These are just a different projection method, and they all have slightly different way of presenting the object and how the line of sight and then your plane of projection are interact with each other. So they probably have like a one's probably like for example perspective projection. You will have a line of sight that converge to a single point or 2 points or 3 points. So they now depending on how the line of sight and plane of projection are behaving or are interacting, you will have a different naming or different style of projection. Uh, and an oblique, obviously, you have your plane of projection is not a 90-degree angle. Axonometric projection is basically a projection that revolves around object that rotates around its principal axis. A multi-view drawing is basically a drawing that requires you to show several views in order to represent a single object. Now, this one, as I said, is a first angle, third angle view. Now, it can be more than one views or, sorry, it can be three views or less than three views depending on the object nature. Of course, you also have isometric view, section view, as well as oblique drawing. So which we'll cover this probably next week because this topic is quite. I'm not saying heavy. It contains a lot of information. So I decided to divide them into two parts. So the thing that we're going to cover today is first part. All right, let's begin. Now, this one is available on your textbook. So this figure really captures how uh, 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 really captures a different, I would say, types. It really represent different types of projection that are available, and it really depends on how the line of sight and plane of projection interact. And based on that, you will have a different representation of an object. Now, this is one example of uh, I'll give you an example. So under axonometric projection, right, you have isometric projection where now you see to represent this object, right, you only need one drawing. So because why you see one view here, one dimension here, one dimension here, one dimension here. So these are called pictorial projection. Now, pictorial projection is not only just axonometric. So any object that can be represented uh, can be drawn can be represented just by one drawing that showing all three dimensions are under category of what's called pictorial projection. But multi-view projection, because you're viewing them under two dimension only, you only see a certain, I would say, front of the object. So in order for you to fully represent the object, you need multi-view drawing. So as you can see here, perspective under perspective projection, where line of sight and plane of projection converge to on 1 point, 2 point, or 3 point, they will give you a different naming of perspective projection. For example, here you have a 1 point perspective projection, a 2 point perspective projection, 3 point perspective projection. They're all the same in the sense that the line of sight, they are linear. Linear here means a straight line, but they are not, I would say, parallel to each other. It's a not parallel projection because line of sight, they kind of converge, right? It's not parallel. The line are not parallel. But of course, this has This converge on 1 point, this converge on 2 points, this also converge on 3 points. Now, under parallel projection, where from the object features to your plane of projection, the line are always parallel to each other. So you have oblique projection. You also have axonometric projection. You also have multiple projection. These are under parallel projection style. But what are the difference between oblique projection and orthographic projection? So oblique projection is basically the line of sight, your line of sight and plane of projection where the imaginary piece of papers are not 90-degree angle. So, okay. So yeah, the drawing will be slightly different. Now, under orthographic projection, you will have axonometric projection where the object is slightly revolved around its principal axis, and multiple projection, as I said, first angle, third angle, where it is viewed from just one front. Now, but the similarities for orthographic projection is that the line of sight, which are parallel to each others, and they are connected to they interact with your plane of projection, and the plane of projection to line of sight is orthographic or 90-degree angle. So those are the what is it called? The classification of projection. We already covered this, but I'm just going to give you a recap. Now, the thing that we're going to discuss today is axonometric and oblique projection. How is it? How we plan to draw, and what are the features of it, and then what are the limitations? What are the advantages? Now, under axonometric projection, let's say you have this cube, right? Let's say you have this cube or this object. Now, in order, by definition, axonometric projection is basically a projection where the object is revolved around its axis, principal axis, x, y, and z. Now, I have a cube here, right? If you see a sentence in the textbook here, it is object obtained when object is rotated on its axis, one or more, to reveal multiple sides, giving them a 3D appearance. Now, of course, if you have this, what is called this object, right? This as an object. If you rotate around this axis on the z-axis, you just see 2 dimensions. So you need to also rotate at a certain angle, a certain axis as well, so that to reveal this side, as well as this side. Okay. Now, let's say an animation on how does it work. So I have an object here. Now, this is your line of sight. This is your plane of projection. These are your object, which is a cube. Now, let's say the features that you are focusing on is A, B, C, D. Now you focus. Now it is parallel and normal to the picture plane or your plane of projection. Your what is called? Yeah, your plane of projection. Now what you see is just this object. What you're going to draw is this object. Now it represents 1 dimension, 2 dimension, 3 dimension, and it appears 3D, right? Now how does it create it? Right? First thing first, you basically rotate the object along a certain axis. But before that, let's check out what are the type of axonometric drawing that are available. Number one is isometric, number two is diametric, number three is trimetric. What are the difference? Now, if you see for isometric, all angles here are equal. So B, A, and C are equal. So since these are 360-degree, so A, B, and C is equal 120. What are diametrics? Diametric drawing is basically a drawing where the angle of the axis, two of them are same, but one is not same. So they have slightly different appearance. So maybe in this case, A and C are the same and B are not the same. So you can do some calculation. Now, trimetric is basically a drawing where these are isometric appearance first. Now they are rotated such that all of the angle are not the same at all. So become like this, and none of the angles are equal. Now, as you can see here, all of them are rotated along this axis, but and all of them are also showing 3 dimension. But as you can see, the way it appears in a piece of papers will be different. Now, trimetric, none of the angles are equal. You have to remember, one of the limitation of axonometric drawing is that it does not really reveal the true size of the object because the object here is foreshortened by certain values. Now, isometric here, all of the what is it called dimension, right? They are foreshortened. This one they will be foreshortened uh, uh, foreshortened by same value because angle are the same. Now this one, two of them are foreshortened by the same value but not B. They are also B also foreshortened but different value than A and C. Now for A, B, and C, all of them are foreshortened at a different rate. Okay, what does it mean by foreshortened? If you see here, this line, if you measure, you probably will not get the actual dimension of distance because it sometimes axonometric data doesn't reveal the true images and not true as a dimension because once you rotate and then once you represent them in 3D, some of the objects become distorted. That's what it meant, and they are distorted at the different values. Now these are the axes. Axonometric axis is basically this X, Y, and Z, if you will. They also have the same. They also have the same axis. Now, what are oblique projection? The only difference here is, okay, first of all, they are the same with the isometric, diametric, and trimetric, except in the sense that the line of sight are parallel to each other's, and the object created have a 3D features. It shows all 3D, three dimension, okay, x dimension, y, and then z dimension. It has 3D appeal. The only difference here is the uh, visual ray of light are parallel, yes, but the plane of projection, your plane of projection are not 90-degree angle. So they are kind of tilted by some value. I don't know what are the values, so we check out. Now let's say these are the object, cube ABCD, your plane of projection, but not 90 degree. Your line of sight, same thing. So when they are represented at a different angle, so what happened here is you still have a 3D object, but it's slightly different appearance. Now, these are one example, two examples. So what are different types of oblique drawing? So in this case, you have this object, this oblique drawing, and these are also oblique drawing, where the only thing that make a difference are the angle between horizontal line and whatever features here. Now, they have different name. Let's see, type of oblique drawing. You have a cavalier here. Cabinet, I think is this one. I don't really remember. Yeah, cavalier is 45. Cabinet is also 45, but they are slightly different. Now again, they are what makes it different is just this become full scale, this become half scale. All right, isometric projection and isometric drawing. Okay, moving on. Isometric projection. How it's gonna be created? It's quite simple. You have an object. First, you represent that you make it face parallel to the front face, parallel to the what's called planar projection. Okay, now when you create those, you're going to create a square because it is just two dimension. Now you rotate first about 45 degree on the vertical axis. So you just rotate like this. Now you will see you will reveal two dimension, right? Which is like this. And after that, lastly, what you have to do is tilt by 35-degree angle and 35 degree and 16 minutes, and you will get a 3D isometric projection. Now, this will depend on the angle. So, depending on the type of angle here at this principal, this axonometric axis, you will have a different name: isometric, diametric, or trimetric. All right, moving on. Let's see. Now, as I said, all edges are foreshortened about 0.8 times. So, it's become shortened because this one reveal a true dimension, but once you rotate and tilt and represent them in a pictorial mode, then it becomes foreshortened. Now, if you want to have a full scale, it should be drawn in an isometric axis. So what does it mean here? Now, the normal X, Y, and Z axis, right, cannot really reveal the full distance of the drawing that are represented in isometric projection. Now, you cannot use the square grid papers to draw. You need a kind of like a triangle-based grid papers, which you will do manually in the lab section. So true projection, which one is true projection? Which one is the isometric scale? Now, if you see a true projection, right, as is, actually it was foreshortened. Actually, the full scale should be a lot larger because again, this is just the nature of isometric problem. Now, isometric axis does not necessarily occurs at the here. Okay, now let me find a good at here. It can be below here, it can be below here. It can be any points at the edges of your object. So depending on which one you choose, you will have a different, I would say, view style of the object. Now, just an example, regular isometric object of this, regular isometric drawing of this object is just like this. So you see here, you see here, you see here. Now, the axis here is this point. Now, basically what we did is just we view looking down. That's the how the object appears. Now, reverse axis isometric is basically you view from bottom, so you will reveal the bottom part. This would be very useful if you have features at the bottom that you would like to see. Basically, you're just looking at like this, you know. And then you also have long axis isometry, where it represents a say they have a slightly different different appearance. This one you are looking from the right or from the left, depending on the situation. But all of them are isometric projection, and all of them have either isometric, diametric, or trimetric, depending on the angle. And they are all pictorial projection. They are all parallel projection, and they are all orthographic to projection, meaning that the line of sight and your plane of projection are 90-degree angle. So you have to remember what are differences, similarities between all of the different type of projection. Now, distance in the isometric zone. As I said, when you represent the object in isometric view, okay, or any, yeah, in isometric view or in pictorial projection, it does not really reveal a true length unless they are exactly in its isometric line. Because why? As I told you before, it is foreshortened. So it doesn't really reveal the exact length unless it is in the multi-view projection. Now, the only thing that are true line is isometric line. Okay, they are parallel to the isometric axis. So, okay, let's check out. Now, as you can see, if I put isometric axis here, should be, wait, isometric axis is like this, right? Now, this line is parallel to this line. Now, these are actual length. Now, this one is a true length. If you measure, these are true length because they are parallel to the isometric axis. Now, this one, okay, is parallel to this. And finally, this line is parallel to this. Now how about this line and how about this line and this line? These are not even parallel to any of the isometric axis, meaning that if you measure using a ruler, the line length is probably not true. This is a true length. So yeah, the one highlighted in red is not parallel to the isometric axis. So these are non-isometric lines. And the one in the black color is an isometric line because they are parallel to the isometric axis. Now, how to draw this? I don't want to spend too much time on how to draw or draw or sketch manually because number one, we're going to use AutoCAD. Number two, it takes time. And then I cannot just simply teach you how to draw lines because it really a matter of your hand. It's basically depend on your handling skills, pencil handling skills, your details, level of details and stuff. But I'm just going to show you quickly because this is just like a do and don'ts when it comes to isometric drawing. Sometimes you don't really have to follow, but maybe this is probably the best method. Now, this is just, as I said, this is just telling you, this is just telling you, the next few slides just telling you how to sketch from the object. Okay, first thing first, okay, you position the object, okay, based on whatever isometric uh, angle requirement, like this. And you set your isometric axis, so you draw. And then sketch enclosing box. What does it mean here? It's basically so enclosing box here is basically the largest, say, the largest dimension of all the of from all axes. It is basically if this object It's basically this object before it's being added details. This is kind of like a it's kind of like a basic object, but this basic object haven't been carved out yet. So these are your enclosing box. Then you add details where you do something like this, and something like this, and then you begin to add lines, darken visible line. As I said, visible line and these are construction line, by the way, if you will. Visible line and construction line, they have a different thickness. So make sure to have a different thickness to represent different lines. That's the first method. Okay, these are just the same thing, but you repeat the same method. These are a few examples, but the object here is more complicated. Now, you said that your isometric axis can be here. It can also be here. So up to you. You can all be here, but they are all parallel. No, you select isometric axis, you position your object like a 90. So basically you have a, how do you position? Let's say you have the angle here, right? So the object should be here to here. Angle should be 30, 30 on the left hand and right side. Now, sketch enclosing box is basically the largest square without, before you add details. So you have the largest, so you sketch. Now, then you add details. Basically, all of them are just parallel to each other. Now this is quite simple because you just all of the line are following the isometric line, but the one that are not isometric line, you just simply do last because you just simply need to connect the dots. And this is just a few examples. Yep, and then lastly, darken visible line. Always darken visible line to distinguish between uh, construction line and visible line. Now, just to give you a heads up, in isometric sketch or drawing, hidden lines are omitted. Yep, unless we are doing a multi-view projection. So unless they are absolutely necessary to completely describe the object. So again, oftentimes it is you don't have to create a hidden line unless they are absolutely necessary. Okay. Let's see. Now again, when you have a when you want to do isometric projection, right? I mean, if the object is quite simple to recreate if you have a front view, top view, and side view that are normal to the surface, meaning that they are parallel to the what is it called to the this axis, and then this axis, and then this axis, because so bottom view is also the same. Now, what if object has inclined surface like this, right? You have inclined surface. So these are non-isometric, the rest are isometric. So how do you want to draw them? Again, I don't want to teach you how to draw, but we'll just see what is how it's being constructed. Yeah, this is how it looks like. And an object also, one more example, object has inclined surface, where this inclined surface are non-isometric lines. So how do you want to create them? Again, just it always begin with the selecting or creating your isometric axis, and then you add details. Okay, these are one last examples where I have a multi-view projection here. And then how do you want to create what is it called isometric drawing is just just following this step. But this one you probably need some imagination on how to kind of translate this multi-view projection to a pictorial project. It's actual 3D object. Yeah, you simply connect the dots and make sure that the one that are parallel to the isometric line is connected correctly. Now the reverse is basically when you select a different isometric what is it called axis. Now what will happen? Okay, it will be nice if the if it's what is it called it will be really straightforward if the object is what is it called is drawn in multi-view because it is showing you the true length, distance, and shape. There are no distortion. But isometric drawing, a circle appears to be an ellipse. So when you measure, you can simply use the measurement as its true length. So for example here, right? So and again, this one is a method on how to sketch, but again, it is ellipse in isometric projection. So this is just telling you how to draw an ellipse. So I don't want to go into details, but you will see you draw something like this, and that's it. And then you connect the tangent point. But of course, we can construct this in AutoCAD, but it's good to know at the very least, if you have no other choice, you draw that manually using this step. Okay, this is on how to draw isometric ellipse with using an instrument, meaning that you have a the first when you have like a protractor, you have a ruler, you have those the what is it called like a needle thingy, pencil, stuff like that. Now you can use a four center method. Again, you can read all of this, but the idea is you can simply see they create like a kind of like a uh, in the square. Okay, they create like a how should you have a diamond and they create this drawing. I don't know how to explain this, and I connect, and then you simply connect the dots. These are the examples of a plate having a circle through the plate. These are just a few examples of a plate drawn in isometric projection where it has circles, right? If you remember, the circles need to be drawn in ellipse so shapes. So this is how it's being drawn, and that's how it looks like. Now, again here, these are hidden line, by the way, but if you remember, you don't have to show hidden line, but only a visible line. Visible line, these are visible line. Now, irregular curve in isometric drawing like this, okay, this is definitely really difficult to create. So how are you going to do this? So what you do is you just simply draw kind of like a few mini points and connect them. The more points you have, the better. You see? Basically, you create it's kind of like a derivative thing where the smaller the points, the interval you have a more accurate point. So as you can see, this green point is represented here. You just keep continue making points, and then eventually you connect the dots, and then you make a parallel line as well. Now it's going down, and finally connect the dots, and there you have it. Now oblique sketching, as I said before, the only difference here is that your plane of projection and line of sight are not at 90 degree angle. Okay, you might be asking me, okay, why do I need to know this? Again, all of the drawing have their own place in the engineering drawing world. You know, some object better shown require better use a certain views. Some don't. Really depend on. Now, so this oblique projection very useful if you have a front part of your object having a circular shape. Because as I said before, when you have isometric drawing, you have a circles is is distorted, it becomes an ellipse, right? So what if you have an object where it's really crucial for you to show that this object, especially those circular objects, this which is the important features of the particular object, but you don't want to make it distorted because it's going to make it really weird. So you want to make sure that the front part is always nice and without any distortion. Now, these are good examples where you have this, I don't know, maybe this one is probably like a clamp or something like that. This is probably kind of like a handle or something. Okay, but they all have front of it circle. Now, as you can see, these circles are not exactly distorted, but you see, now it shows the features, the front part of it. Again, object orientation guideline for this also applies for multi-view projection. Now, the longest dimension of an object should be parallel to the frontal page. So these are good. This is not good because number one, for this particular object, right? Number one, you see the important feature to highlight here is this. This should not be distorted. But if you see this become distorted and kind of like a doesn't show the actual the it doesn't it feels wrong, you know. Now these are the object. If you view from there here, right, it just seems wrong because I you would probably would like to highlight this circular shape or nature of the object because this one seems wrong, you know. Okay, you might be asking which orientation is better, right? So which obviously this because this one of course you viewing them in a of course from the previous guideline, right? You should choose this because these are the longest dimension. But as you can see, these are distorted because why? I think for this particular object is really critical for you to show the circular nature of this particular object. So viewing them from here is important. Now this is where and this one is basically normal to the plane of projection. You want to show the circular nature because this seems wrong, seems distorted. Now, how do you want to draw oblique? So you have an check here. It should be front. It should be parallel. This one is like first thing first should be front. It should be parallel to the plane of your piece of paper, if you will. And then you create 45-degree angle, and then you kind of like estimate lines, how long it is. Estimate depth. You complete the object. Now, if I go back once, right? Now you see this particular object really shows the front nature of the object because these are not exactly distorted. You see that it's kind of true. If you view them in a isometric drawing, this probably become at an angle, right? Become slightly distorted. This shows reveal the front portion of the actual object. Now, just another examples. Now, if you see here, the circles remain circles. It is not distorted. So from here, right, they are using this particular plane as the parallel as a plane as a front that are parallel to your plane of projection. Same goes with this one. Now, for this particular object, I'm just going to go over very quickly. Oops. Now you see, as you can see, this object on oblique style, they show the front. This is very useful if you have an object that has a feature, circular feature that you want to show but don't want to make it distorted. All right. Again, the last few slides just tell you how to draw. So I don't know what else to explain because again, we're gonna draw using AutoCAD, but it's always good for us to know if we have no other choice, if we are limited in terms of that let's say your somehow your laptop is gone, right? Your AutoCAD just gone, so you need to draw them manually. This is the method that you can apply. All right, that will be all from me. Thank you all for listening. I'll be more than happy to answer your question. Yeah. Oh yeah, before I forgot, the password is 002004. Password for tenants is 002004. I think I should mention about this like in the middle of the in the middle of the what is it called in the middle of my lectures, but somehow I just so caught up with explaining all of those to a point where I forgot. Password is 002004. Again, thank you all for listening. Don't forget to record your attendance, and I'll see you next week. Happy Hari Raya.